For just a few seconds, no one understood what was happening.
As night fell over Rio de Janeiro, passengers boarded Air France Flight 447, each with their own story.
The flight deck was in the hands of a young, confident crew, trained, focused, and prepared for a long night over the Atlantic.
Inside the cabin, families, friends, and strangers prepared for a quiet overnight flight, never imagining it would become unforgettable.
With a roar, Flight 447 lifted into the night, its passengers unaware of the storm that waited far beyond the horizon. At cruising altitude, the Atlantic stretched endlessly below, silent, calm, and hiding what was to come.
As the cabin drifted into peaceful sleep, no one sensed the storm building ahead. A storm that would soon test everything.
The intertropical convergence zone awaited ahead, an unpredictable region of towering storms that few pilots take lightly.
The weather radar warned of a tightening corridor. Storm cells grew larger, merging into a single wall of turbulence. A soft shake rippled through the cabin, barely noticeable, yet enough to stir those who slept lightly. Following procedure, the captain stepped out for his scheduled rest, leaving the young first officers in charge. Ahead, a towering wall of cloud dominated the horizon. There was no turning back. A gentle vibration hummed beneath the cabin floor, nothing unusual, yet enough to draw quiet attention from a few awake passengers.
The returns are tightening up ahead. We have magenta.
Requesting immediate deviation, vector 280.
Turbulence is severe. Hold on.
A sharp jolt rippled through the cabin, strong enough to snap passengers from their uneasy sleep.
Everything is all right. Please remain seated.
They steered left, trying to slip between two towering storm clusters. But the sky was tightening around them.
Cabin crew moved quickly, locking every loose item. Their calm faces masked the tension building beneath them. A violent updraft slammed into the jet, sending it surging upward, every instrument reacting at once.
Panic spread through the cabin. Every violent shake whispered the same unspoken fear. This storm was unlike anything they'd felt before.
As Flight 447 pushed deeper into the storm belt, visibility dropped to near zero. The sky closed around them. Tiny fluctuations appeared on the airspeed display. Subtle, easy to miss, but the first hint of something unusual.
Turbulence strengthened, rolling through the cabin like a wave. The unease grew heavier.
Invisible to the crew, dense ice crystals swarmed the aircraft's sensors, clinging to metal in seconds.
Without warning, the airspeed plummeted. A critical reading, suddenly unreliable.
A violent jolt shook the cabin, sending fear surging through passengers who now realized the storm was far from ordinary.
Outside, the storm surged with new force, winds twisting unpredictably as thunder rolled beneath the wings.
Then, without warning, the autopilot disconnected. A once stable jet now demanded manual control in the heart of a storm.
A powerful updraft slammed into the jet, forcing its nose upward, an unstable position at cruising altitude.
A piercing alarm shattered the cockpit, stall warning. Something was terribly wrong. The jet was now at the mercy of the storm, buffeted violently as the atmosphere turned hostile. Fear erupted in the cabin. Every jolt felt stronger than the last, and panic began spreading like wildfire.
Suddenly, all three airspeed indicators collapsed. The aircraft had gone blind to one of its most critical measurements.
Driven by turbulence and pilot input, the aircraft pitched sharply upward, far beyond its sustainable angle.
Stall! Stall! Stall!
A continuous stall alarm filled the cockpit. The sensors threw screw.
The A330 entered a deep aerodynamic stall, its wings no longer producing lift. Though nose up, the aircraft was falling.
The aircraft dropped violently. Passengers felt their bodies lift against their seatbelts as gravity twisted around them.
The stall deepened. Despite their efforts, the young pilots were fighting a physics problem no control input could solve.
The aircraft was no longer flying, it was falling. Nose up,
engines running, yet dropping through the sky like a stone.
With the aircraft plunging and alarms erupting, the crew called desperately for the captain to return.
The captain, jolted awake by the alarm chimes, fought the shaking aircraft as he raced back to the cockpit. The captain arrived to a nightmare, an aircraft mired in a deep stall, falling thousands of feet per minute. Outside, the jet spun through chaotic air currents, its wings unable to regain lift as the storm dragged it downward.
For a brief moment, the turbulence paused, and the silence was worse than the storm.
Dual input.
We're stalling! Pull up!
Both side sticks were now in motion, each pilot making opposing commands. The aircraft plunged faster, 10,000 feet per minute, its nose lifted high, yet sinking rapidly through the storm.
The captain fought to coordinate control, but the aircrafter's attitude, alarms, and chaos made every second harder.
Another violent drop tore through the cabin. The final minutes of Flight 447 were slipping away.
10,000 feet passed in seconds. No response, no lift, only the relentless pull of gravity.
As Flight 447 dropped below the final cloud layer, the Atlantic revealed itself, still miles away, but approaching fast.
Then, just as suddenly as it started, the stall alarm went silent, misled by invalid speed data. The silence offered no safety.
The Atlantic Ocean loomed closer, rising fast to meet the falling jet.
For a moment, gravity vanished.
The numbers fell faster than any command could counter.
5,000 feet! 4,000 feet! Pull up! Pull up!
Below, the Atlantic rushed upward. The final seconds of Flight 447 were slipping away.
Pull up! Pull up! Pull up!
Whoop, whoop! Pull up! Pull up!
We're going down!
Below, the Atlantic's surface drew closer, silent, dark, and impossibly near.
Inside the cabin, a profound quiet settled in. A moment suspended between fear and finality.
In the cockpit, the crew fought until the final second, calling commands into a storm that no longer answered.
At 2:14 a.m., Flight 447 disappeared into the Atlantic. All 228 souls aboard were lost.
With daylight, the search intensified. Aircraft scanned the ocean for any trace of Flight 447.
Naval ships from Brazil, France, and several nations converged, forming a vast search grid across the remote Atlantic.
Within days, search teams discovered floating debris, confirming the worst fears. Flight 447 had been lost.
Among the drifting remnants were personal belongings, silent, heartbreaking reminders of the 228 lives aboard.
Beneath nearly 4,000 meters of water, the search for the answers and the black boxes had begun.
The mid-Atlantic ridge concealed its secrets in a maze of cliffs and trenches, an unforgiving world where the black boxes lay hidden.
At last, the first unmistakable pieces of Flight 447. The wreckage lay quietly at the bottom of the Atlantic.
The full debris field came into view, an enormous, silent footprint of the disaster stretched across the ocean floor.
Then, a breakthrough. The bright orange casing of a flight recorder emerged from beneath the sediment.
Carefully, the ROV lifted the first black box. At last, the crucial evidence was on its way to the surface.
After 2 long years, the flight recorders were finally recovered. Soon, they would reveal exactly what happened aboard Flight 447. The flight recorders were brought to the BEA laboratory in France, where investigators prepared to uncover the truth locked inside them. Investigators carefully extracted audio from the cockpit voice recorder, recovering the final 2 hours of cockpit conversation.
The flight data recorder revealed over 1,000 parameters, each one helping rebuild the final minutes of Flight 447.
The data confirmed the sequence. Ice crystals blocked all 3 pitot tubes, causing the autopilot to disconnect instantly.
The timeline exposed a critical pattern. A continuous nose-up input kept the aircraft trapped in a deep stall.
For the first time, the BEA reconstructed the final 447.
Investigators turned to human factors experts to understand how highly skilled pilots could become overwhelmed so quickly.
Unlike traditional aircraft, Airbus side sticks do not move together. One pilot cannot see the other's inputs.
Regulations at the time required stall recovery training, but not in high-altitude cruise conditions, where aerodynamics behave very differently.
At high altitude, the margin between stable flight and aerodynamic stall is razor thin. Once the stall begins,
it was not a single failure, but a chain. Weather, sensors, training, communication, and cockpit design all converged into catastrophe.
It was not a single failure, but a chain. Weather, sensors, training, communication, and cockpit design all converged into catastrophe.
The flight data recorder held over 1,300 streams of information. Engineers decoded each parameter.
Pitot tubes rely on unobstructed airflow. In rare conditions, supercooled ice crystals overwhelm heating.
When airspeed became unreliable, the autopilot disengaged. The aircraft shifted from normal law with full
With the captain resting, cockpit authority transferred to 2 co-pilots. Investigators found that this transition was...
Multiple warnings struck the co-pilots within seconds. The BEA concluded that cognitive overload severely impaired their ability to interpret situation. Airbus stall warnings deactivate when angle of attack values exceeds certain limits.
The BEA's analysis of cockpit dialogue revealed overlapping commands, missing callouts, and moments of unstructured communication. BEA investigators concluded that Flight 447's loss resulted from a convergence of failures.
enhanced self-condensing airflow geometry.
Airlines worldwide adopted new training modules for unreliable airspeed. Pilots now practice recognition and
ICAO and EASA introduced sweeping changes. Regulations now require more robust sensors.
The tragedy led to significant research in deep stall prevention. New aircraft now use sensor fusion and
In the years since Flight 447, the aviation world transformed. The BEA synthesized thousands of data points into a single, structured conclusion. Flight 447 was lost as
advanced aerodynamic models show how deep stall conditions lock an aircraft into a high-angle descent. Beyond this threshold,
studies revealed that heavy reliance on automation can erode pilots' manual handling skills.
aviation safety models show that disasters rarely stem from a single failure.
global data confirms the impact of new training standards. Stall response accuracy increased, reaction times improved.
In Brazil, a memorial overlooks the vast Atlantic. Here, families gathered.
In Paris, families gathered to hear each name spoken, an acknowledgement of lives cut short.
months after the crash, search teams continued their mission. Their work brought closure to families waiting for answers.
Far below the waves rests the wreckage of Flight 447.
Play truths. The tragedy sparked global reflection. Airlines examine procedures, training, and cockpit communication standards. Today, thousands of aircraft cross this path safely. The lessons learned from Flight 447 accompany each one.
From sensor icing to automation reversion, from aerodynamic stall to cockpit confusion. Behind every aircraft is a crew, and behind every crew is training shaped by tragedies of the past.
Today, millions fly every day under safety protocols strengthened by the lessons of Flight 447. Aviation grows.
Aviation evolves constantly. Each incident teaches us not to fear the skies, but to understand them more deeply.
From every lesson learned, the skies grow safer. This is the lasting legacy of Air France Flight 447.